Alright, now we move on to table 2. And I copy pasted it out of the lab manual just to, I didn't have to keep back and forth referring to lab manual. It's much easier to have it right in front of me. Right, so let's see. So we can copy, paste, and paste again. And so I wanted to show you something. So I have density. If I want to put the plus minus like this, Excel doesn't like just putting a plus sign there for some reason. So I had to put this apostrophe first. Plus slash minus density. There we go. Nice. All right. So, I see what's going on. Okay. I'll get to this in a minute. The spread here, the standard deviation. But anyways, all right. So I think now it's time to put the grid on it. And so I can right mouse click. There's a little drop down box here. All borders. Now we do some housekeeping. We want to merge a few things. Where did it go? Oh yeah, right there. Merge and center. Yeah, and it's a drag that now the measurements were in millimeters. Now they're in centimeters. That's what spreadsheets are for. And notice I use that little there's a caret character that's above 6. Let's see, merge and center. Merge and center. Oh yeah, I want to merge and center these guys. And move that to the middle. And oops, too far. Merge and center. And merge and center. Now, we probably could have gotten a little more clever here, because rulers, calipers, micrometer go across there. So we won't be able to use a fill handle here so easily. Okay, so you may have noticed announcements about I noticed I'd made a bad mistake in the table 2 and thought I could patch things up, but it's I'm just gonna have to re-record this part. So anyways, in fact, you don't even know about pasting links. So what had happened is, you can see here, if you look across, see diameter, length, and plus minus length, they're all the same number. I think I did fix that one up. I fixed this. But I used the fill handle improperly there. So now let's fix it up. So this part is kind of tedious. Now, you see numbers in here, and in the video up till now, it was just the empty grid. So in fact, I am going to, as much as I hate to do this because it's a lot of work involved here, but I'm set to make the thing over again. I'm going to just clear the contents. And so this is basically where the video was at, where I cut it. I kept the first little bit of it. So we're at the point where we're ready to start filling in stuff. And I want to make sure I have a really large monitor, which I may have said a little while ago. And so I have a window on it. So I just present a small one for the recording so it fits on your screens properly. Okay, so let's go down the line. We need the mass, and we're going to use all the average values here. So this is the average of the mass. So we put here equals, and then we just click the box here. And you do it that way that because if you happen to change these numbers, this one will change along with it. And then the uncertainty is here, equals, and we're using this standard deviation as mentioned before, the spread. And this, again, the standard deviation, without going into it too much, is a way to create an average plus minus. It's a plus minus on the average of the measurements you actually took, and because what will happen? Oh yeah, right. It's something I forgot to say. Even though the instrument may have only a plus minus of 0.1, if you take a lot of measurements, that's the way you can beat down the plus minus. It's pretty cool, huh? All right. So let's see now. Now we have to get, for ruler, calipers, and micrometer, we get the diameter. And we have to convert from millimeters to centimeters. So this is equal to the average diameter measurement over here. And we have to divide by 10 to go from millimeters to centimeters. And then, well, let's just go down the line. So this is equal to the diameter measured by the calipers. Here we go. Right? Yeah, divide by 10. And then equals to the diameter measured by the micrometer. Here it is. Divide by 10. And let's check our sig figs. 3, 4, 5. 3, 4, 5. Is that right? Yeah, great. So it worked out nicely. Excuse me. And now we have to do a similar thing for the plus minus. Now I think, no, we can't do the fill handle because here they go up and down, and here they go left and right. And there is a transpose copy where it will flip it, but I want to keep, you can only do that for the values, and I'd rather keep it so these cells are linked together. So you go equals, and a plus minus of the diameter for the ruler, divide by 10, and plus minus for the calipers. It's on the diameter. Yeah, this is pretty tedious, huh? Nope, wrong one. Here it is. Divide by 10. And plus minus for the micrometer. So that equals here, divide by 10. All right, so we have to check our sig figs. So here we only have 1, and we need 3, 2, 3, and now we need 4. 1, 2, 3, 4. And now we need 5. There's 1 there. 2, 3, 4, 5. 1, 2, 3, 4. Oh, 1 more. And so 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. These zeros here don't count. And now you really see the power. Well, let's take a look here. So if we averaged, yeah, you see in both cases we beat the intrinsic error of the excuse me, of the device by averaging and then taking this, what's called the standard deviation, which just gives you the plus minus on the average. Sweet. So this one here, let's see, this has got 3 sig figs, 3. This one, so we have to increase the sig figs here. See that? 3, 4. and 3, 4, and this needs to be 2, 3, 4, 5. Isn't that amazing? Now we didn't quite make it here, but remember, there's some mystery in the numbers here. No, I'm not trying to be disparaging of whoever's data table I used. Oops, so that one got to be too big to fit in there. There we go. Amazing, huh? And then this one has 2 sig figs, so we gotta make that 3. Yep. And so this has to be more sig figs, 2 sig figs, 3 sig figs. Sweet. All right. So I'll leave it to you guys. I'm gonna pause this video and I'm just gonna fill this in. It's tedious. You don't need to watch me doing it. It's just the same as before. Well, maybe you should. Let's see. It's repetition. All right. So this is the length equals ruler length here divided by 10 equals caliper length. Here it is, divided by 10. And micrometer length. No, here. All right. Equals micrometer length divided by 10. Nice. And then we have to do a similar thing here. Equals plus minus length for the ruler divided by 10 and equals plus minus the length for the calipers here divided by 10 and for the plus minus for the micrometer equals here divided by 10. Okay, so we have to get the proper number of sig figs, 3, 4, 5. So this is where we might consider scientific notation. So that's 2, 3, 1, 2, 3, 4. So there's 1 there. 2. Oh, what happened? Oh, it was rounding off. Okay. So that's 1, 2, 3, 4, 5. So it looks exactly like this, except there's an extra 0 there because we divided by 10. Okay. So now we get to the trickier parts. First thing we can do, though, let's create the volume because that's pretty easy. It's grams per centimeter. Oh, wait, no. Volume. So we need a loop. So we're going to create a form of the. I'm looking for my Gatorade. Okay, so right, volume, and we need to might as well go right ahead and do the plus minus on the volume. So this is the the equation for the plus minus on the volume in the manual. And the problem with this is it just goes so far, but then okay, so this one is made up by thinking about the standard way to think about volume, which is length times width times height. So standard, like volume of a, and it's defined as length times width times height. The trouble is we have a cylinder, and the volume of a cylinder, so this is basically a rectangle or A rectangular prism is the official title. But for a cylinder, it equals pi r squared times the height or the length. So what we can do here is we want to turn it into something that looks like that. And first of all, and two things we need to do. We have diameter, not radius. So we're just going to remember that radius equals d over 2. So this becomes pi times d over 2 squared times the height, which is going to equal pi over 4, because 2 squared is 4, d squared times the height. And then we're going to take it one more step, and we're going to call it pi over 4 times d times d times h. So these two guys are going to be our L and W, and that's going to be our H. So then we can take this guy here, the error calculation, the error propagation equation, and we can say then that the plus, and sigma is just a fancy symbol for plus minus, equals to the volume, and we're going to use these square brackets for the square root sign. So our first one is d, so it's plus minus d over over d squared plus minus d again over d squared plus minus, well, h is L over L squared, and then the whole mess gets square rooted. Okay, so let's move up to putting this into the spreadsheet. So first of all, we know that the volume, we came up with this new formula, pi over 4 times d times d times L. So we say equals, and we just type in pi, open, close parentheses, so then that's Excel knows that you want to use the value pi, not times, divided by 4 times the diameter here times the diameter again times the length. Boom, there it is. And now we can use the fill handle. And now we have to just change the sig figs. This has 3. This one needs to have 4. Oh, you can't see. I touched I clicked on the home button here, and so that way I could get back to these commands. Let's see, I might as well try making this full screen in the window I made for you guys. Okay, so I'm here. So now I need to make that 4 sig figs, huh? 3, 4, and this one needs to be 5. 4, 5. Okay, huh? Nice. So let's do the calculation of the plus minus. And there's our formula down here. It's a little tricky to type this in. We have to pay careful attention. So it equals the volume itself times, now we're going to use this a built-in command, square root sqrt open parentheses. And now we have to create these 3 terms that are inside of here. So we do another open parentheses, and that's going to be the plus minus d divided by d, and and then we use this caret symbol, and that's shift 6 squared plus open parentheses, and this time the same thing, plus minus d divided by d, close it, square it, and now we need the last term, that is the plus minus length divided by the length, and now we square that, and we close the parentheses on the square root function. Notice how Excel it colors the parentheses to help us make sure we've opened and closed the equal amount of them. And there's the error on this. And once again, we can go down, and we have to get the number of sig figs right. So that's 3 and the 2, 3. Now wait a minute. We have to be careful now. Let me think about this for a minute. Yep, I think I made a mistake here. So the standard bit here is that you assume that the last one, excuse me, I'll pause this for a minute. It's okay. It's not a big deal, but I just want to make a correction here. I was saying number of sig figs here, and I'm looking on the left side here. And it's not, you don't count sig figs, you count the number of decimal places. So this one only has the 1 decimal place, this has 2, this has 3. So you're always presuming that the last one is the one that was estimated. And then standard deviation, let's think about this. So that means that we have to make this to have 3 decimal places. No, this should be able to be better. So this is a challenge here because there's lots of math involved in creating all these, and I'm trying to present to you guys quick and dirty statistics. So here's what we're going to do. Because the instrument error is 1 decimal place, any measurement we take can only have 1 decimal place. Now because we're making an average, so we're going to use the standard deviation function, and for a quick and dirty physics 1100 rule, all we're going to do is if we take the standard deviation, we're just going to say now we can have 2 decimal places here. So I had 2 here, so I'm going to allow, let's see, so that's 4. So we want to decrease that to 3. And this is, yep, we need that to be 3 because it has 2 decimal places. All right, that's 4. There we go. 3 decimal places. And now this one has 3. So we're going to allow 1, 2, 3, 4. I already did that. And this one here, we're going to also have 4 decimal places. There it is. Okay, good. Now I feel better. I feel much happier about that. So this one now becomes 2 decimal places. Sweet. Now that's what it's called. It's not exactly correct, but it's defensible, and it's good for you guys because we don't want to get bogged down in the math. We want to get bogged down in just the basic ideas. Okay, so now this one here stays the same because we don't divide it. But these guys here, so now, oh, it's simple. See, we have 2 decimal places there, so this one should have 3. That's pretty straightforward. Oops, wrong one. There we go. So that has 3. This one should have 4. Set up. Now I feel much better. So this one has 4, so it should have 5. Let's see. 1, 2, 3, 4. 1. That's hard to do. 1, 2, 3, 4, 5. Oh, okay, to the 8. All right, nice. Okay, so this one, once again, should have 3. Yep. This one should have 4. And this one should have 5. Okay. Nice. So now we have our plus minuses. So we need to have the same number. So this is 2, so this one needs 3. Now give me a minute here. Right, because it's we went from millimeters to centimeters, so we get 1. So we went from having 1 to the right of the decimal place to 2. Fine, 3 here. This one needs 4. And this one is 4. We need 3, 4, 5. Okay. Sorry for the confusion, guys. It's the first time I'm doing this lab class, and I can't, just because I'm a smart guy and I have a PhD in physics doesn't mean it doesn't take me a while to absorb something in the lab manual. And I've had surgery and I've been drugged up and blah 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 blah. And also I didn't even get this class until the last minute. Okay, so now we've got a defensible setup here. We have measurements. The number of decimal places in the measurement is limited by the instrument. We take an average to get the best possible number. And then we use this thing called a standard deviation, which just tells us the plus minus on our set of measurements on the average value. And we're just going to make the simple rule that this allows us to have, where there was 1 decimal place here, we get an extra one when we average. So we get an extra one here across the line. Very simple formulation. It's not exactly right, correct, but it's very close to being correct and good enough for Physics 1100. All right, so now we've gotten our first one here, first set of errors, measurements and errors. It's pretty eerie how that looks like pi, doesn't it? And let's just double check this formula. Pi over 4 times d times d times L. All right. So once again, the density is pretty easy. That's this. Let's just write it out because I don't think we have it here. And that's going to be the mass divided by the volume. So that's why you get, or how you get 2 grams per centimeter cubed. So that one's pretty straightforward. We just say it equals to the mass here. So we're going to enter another little, learn another little trick here, because remember in the past we get a little burned by having this. What Excel knows is that the number 27.4 it remembers cell Q6. It has to assign a cell to it. We merged these 3 cells to make it look like the table inside the manual, and so we need it to always use that value in Q6 when we go down here. So we're going to add these dollar signs. So you look along your top of your keyboards, you should have these function keys, and we're going to use F4. And you press F4 once, and you get these dollar signs. And the dollar signs say that it's always going to look at Q6 every time. And because that comes up to when we use the fill handle, and I'll show you that in just a moment. So we have the mass divided by the volume, W6, hit enter. Now we're going to use the fill handle, and we have to adjust the number of decimal places in a minute. And, well, if there's sig figs in decimal places, so I have to be careful here. Yeah, that's 3 sig figs, 4, 5. That worked out. So we get 3 sig figs here. 4. Oh, wait a minute. This one has 1, 2, 3. Yeah, 4. And this one has 5. All right. Now, just to show you, see, Q6 over W6, Q6 over W7, because different volume, but we only have one mass measurement. All right. So far, so good. So for the plus minus on the density, it's the same formula as before, except now we only have 2 terms. We don't need the third one because we only have 2. We only have mass and volume. Of course, there's only 2 variables here, but we have 3 terms because d times h. So anyways, the plus minus on density, and to save space, I'm going to use the symbol for density rho, equals the density times the plus minus mass divided by the mass squared plus minus of the volume divided by the volume squared, and all that square rooted. Okay, so we go equals to the volume, the density, times, we need the square root function again. Oops. SQRT. And then we make our 2 terms inside, so we need parentheses. It's plus minus the mass. And we need our dollar signs again, so I'm going to hit F4. Divided by the mass. And I'll use my F4 key again. Square it. Then put in our next term. That would be the plus minus volume divided by the volume. Square it. Close the square root. And then now we've got that. And now we just have to add the decimal places. So what did we say? We're going to use one more than these guys to reflect that we've been using standard deviation and averaging. All right, not bad, huh? So, we have to wait a minute. Let's be careful. Unfortunately, because there's only 3 sig figs here, this can only have 3 sig figs. See, that's what's bad. See, we get these much better we get these much better because of the um, um, use of the micrometer, going from the ruler to the calipers to the micrometer. But our scale has got crappy error, and it may be that that scale could do better, but I wasn't there to help you guys, so that's okay. So we have to we have to have them all be 3. But you see that the error still goes down a little bit. So we don't lose it completely. It's just that we could have been really hopeful when we saw this that we'd get something comparable here, but we can't do it. All right. So now I've got this fixed up, and I corrected some mistakes from earlier. And right, so I will get this going on, get it posted up.